I managed to see HTTP coming into, not really coming into existence. Obviously, I was slightly late, but when I started understanding what it was all about, it was around HTTP 0.9. And seeing things change was very exciting and also very helpful because it was very slow. For a lot of folks, when you start using the internet today, for example, many young folks, young people that start to use the internet today, many things are just given, right? Okay, things are supposed to work this way. You open maybe Gmail and you expect to see live email updates and chat and screen sharing in your meet.google.com. All of that is like such a given thing, right? We are used to extremely desktop application like experiences within the browser. But it was definitely nothing like this when it all started. So let's think about the very original times. And there was a time when there were various mechanisms, various ways of exchanging information over the internet. There used to be email. There used to be something called UUCP for Unix to Unix copy protocol. I believe so, if I remember right. Or FTP for file transfer. Then there was remote login that would, that would be very useful. So there was Telnet and then RSH and RLogin, RCP, all of those things to make use of the internet. One of the major needs or major things for all of these utilities was you needed to have access to a remote computer. You needed to have an account elsewhere so you could connect. And if you needed to transfer information, you needed to know some things, either an account or some address of a user so that you could exchange notes or emails, as you would call them, right? Emails also had, and there were news groups also where like one-to-many broadcast, the kind of things like Google groups that exist today, all web-based. There were specific things, protocols that allowed them to happen over the internet. Things like IRC and all those chat protocols, it was a myriad of things, most of them unconnected with the web, right? And if you look at today's world, almost everything we do is inside the browser. So it's a drastic change. The browser is so capable that we have moved almost everything to the browser now. Almost everything. You imagine building something and you can do it in the browser. So how did it begin? When you had so many different things, so many different mechanisms of exchanging information, how and why did it even begin? So as I mentioned, one of the key motivators was, what if I needed information but without the hassles of having an account or having access to some place? FTP for transferring files, at the very minimum, you needed to have an anonymous account. And anonymous accounts were like, it was standards based. I could log into an FTP server using anonymous and a random password, mostly empty or just repeat anonymous. Then I could log into a remote server, copy files. Copy from me to someone else or from some other place to my computer. What would I use it for? So people would do research. They would have PostScript files. I believe PDF wasn't really a thing then, or text files, right? Or data files in which people would dump a lot of their data. There was scientific community exchanging information, right? And they would be published and available at well-known locations. You needed to know where it was. You needed to log in. You needed to get information. And if you had to explore a particular server, you needed to know specific FTP commands. You would cd into a directory, you would do ls, you would get, right? There were binary files which had a different mechanism for transmitting, and text files, you had to change your modes. many of those things that people would do to exchange information. This was definitely not something that we see. I mean, if you imagine what we are doing today, this was a very different era, isn't it? And if we would have continued in the same way, things wouldn't have evolved as well. So what was the most pressing problem according to you? If you start to imagine that I need free flowing information, what can I do? If you had to build a system today, what would you imagine it to be like? Given all of this information about various kinds of applications or mechanisms for exchanging, what would you try? How many of you have done socket programming, low-level socket programming ever? How many of you know what sockets are, or don't know what sockets are rather? Don't know? Everyone knows what sockets are, right? So essentially, if I can write a server process that can listen on a specific port over a specific protocol like TCP, and someone knew how to connect to it and talk to me, I have a mechanism to communicate. FTP, RSH, RCP, Telnet, all of these are implementations of certain protocols, but based on the same underlying framework. They use sockets, right? But there is a mechanism by which people talk to each other. My first step is, what if I could give access to people without them having to have an account? When I open a connection to a socket, there's no such notion as authentication, isn't it? Authentication is more of an application concern. The application understands that I need to authenticate, I need to ask for password, I need to exchange certain secrets before I can give you access, right? So I can write another program that removes this need and pass on information to you. Sounds logical, right? So what if I started doing that? But what would I ask for? That's the next question. So if I connect to a socket, what can I ask for? I want something very simple. So I can say, get me, let's say, some text file that you have. Let's say you have some storage of information in a text file. You know the name of the file, and I could say, get abc.txt. And the server would give you that information, and that's it. No login, text file transferred, right? And hopefully there are no security holes in my implementation. So my implementation makes sure that only a specific directory and its children are exposed to the process or to the client which is connecting. Now, if I can take care of those things, then I have a simple system. I can expose a specific directory and its children over an endpoint. HTTP? Yes, that is the motivation. So the motivation of creating HTTP in a specific way was this. I need a very simple way of giving out information. Okay? But then what's the difference with FTP? I could connect to an FTP endpoint. I have anonymous accounts, and I can ask for a specific file. So what's the difference? Which is used for large? But HTTP gives me GBs and GBs of downloads now, isn't it? No, without streaming, suppose if I had to use FTP, there was a file, FTP doesn't care whether it's a small file or a big file, right? So why would I still not use FTP? Ease of use, considering that with FTP you need to
person should be tasked with that file, and after that, there's added step of opening that file. That's one. And another one would be you don't know what exactly is the file that you're given. It can be a text file, it can be a video file, it can be a so FTP kind of sucks at that.
Okay, so even in HTTP, we have not spoken about the browser yet, right? I am still thinking of transferring the file. I am only at that level yet.
Because the connection persists in FTP and that port is still blocked.
That is one good observation. So in HTTP, we all know today that you connect, you do what you want, and if your work is done, you can close it, right? In FTP, it's a persistent connection. Actually, the original FTP protocol opens two connections. One is a control port and one is the data transfer port. I believe 21 and 22. No, rather 20 and 21. I'm so sorry. 22 is SSH. Okay. So I'm going to hold resources. It's complex because there are two connections. Although there are mechanisms in FTP to use only one connection, because then there used to be firewalls in between and proxies in between. So they had mechanisms to work only on a single connection. But again, FTP by itself was a more complex protocol. What else? So that's where the other sides start to come into picture. I needed to know how to navigate a particular server, and if I'm connected to a single server, and if resources need to be elsewhere as well, there was no mechanism in FTP or the FTP ecosystem to allow me to navigate around or move around. So the group of people, especially I think led by Tim Berners-Lee, they did not just release HTTP. What actually came out was a bunch of things which included HTML and which included a browser as well. And it also included HTML. It was actually a very complete system. Why? Because it wasn't only about going and getting some file. It was primarily meant to get HTML files. So before HTML, there was SGML, and HTML is a specialization of SGML, and HTML was created with the idea of having hyperlinks. And when I say hyperlinks, these are like links across documents which need not necessarily be on the same server. That gave the web, or the first notion or the first version of the web. That's where the power came from. Not only was it easy for me to connect to a specific server at a well-known location, I get HTML. There's a server that understands HTTP, serves HTML. There's a browser that understands and parses and renders the HTML with the links. And now I can follow links, and these links could be on the same server or they could be elsewhere. So hopping across was going to be very easy. It was called the World Wide Web. That was the idea. That's how it was proposed initially.
So DNS also was part of the protocol?
DNS was always existing even before this. So DNS was only a mechanism by which you would look up from a name to an IP address. And that was even required for FTP, for RCP, RSH, or UUCP, and so on, right? Even for email, sending the MX records of your domains. So DNS was in place even before. Okay, and that's independent. Okay, so it was very revolutionary for the kind of things it enabled. And almost everything that we are using today and building upon today, it started from this, but this was the most revolutionary part. Everything else seems more like, okay, tweaks here and there to enable the next level of improvement. So any thoughts at this point? The idea of HTML and HTTP and hyperlinks, all of them together, that was the key defining thing of the internet or the web, the World Wide Web. So what does the yeah. Are you able to see the are you able to read on the screen? Larger than this? Should I move this? Yeah, this one. All right. So let's see an example. Google even today, thankfully, listens and responds on port number 80, which is your non-SSL HTTP, right? So if I do this, and I just do get slash, it responds with the index.html file, rather the file that renders when you first go to Google. Okay, and this was essentially what your original HTTP looked like. Actually, the convention was you would name your files as index.html by convention, and you would have an index file that linked to all the resources that you would want to share on your web server. So the original idea was go connect to an endpoint on port 80, that was the chosen port for HTTP, and say get slash file, as in it seems like an absolute path, but it is a relative path under a directory where the web server would decide that I have to expose everything only under this. Obviously, it would not expose everything from the root folder, right? The original HTTP request. So what we saw here was an example of what was first released as HTTP 0.9. Right? The command that you would type here was extremely simple. Get space slash index.html, right? This is exciting. Yes, I mean, imagine 1990. This is extremely exciting, right? And I want more. When I say I want more, what am I missing at this point?
Now I know what sort of the info this server has. Now can I get more into that information?
So can I get more information? More file types. So this was just HTML, right? What if there was maybe a gzip file which had a lot of interesting data that I wanted to get? What if there was, let's say, a bunch of images coming from Mars rover that you would want to exchange with others. How would you share it? Now, with this basic stuff, that would be a bit difficult to achieve, right? So think about the server. I, as the browser, type this on the socket. Okay, how can I extend this to now get different kinds of files? Well, you would say, what about abc.png, right? I can always do that, right? Or I guess PNG wasn't a big thing then. So JPEG or TIFF or whatnot, right? You could have any of those, right? I could do it. But do you foresee a problem here? What is the problem that you foresee here? This extension is fine. This extension is human given, right? I'm sorry? Yes, I am going to guess based on the extension. I mean, I would end up being Windows and look at a .exe file which may have text, and I might just not be able to process it, right? But that's not a very clean way of doing things. So what would you want? I would want the server to tell me the MIME type of the information that it is giving back to me. And we know MIME types, right? Text plain, text HTML, right? Application JSON, and so on and so forth. They're nothing but types of the file. And why are types important? Because they're hints to the program to figure out how to decode that information. Browsers today, they understand so many different MIME types, they can render them inline. Images can be rendered inline, videos can be rendered inline. HTML has evolved to support all kinds of, like even videos, etc., for example, right? But with an ability to do or type only this, how would I get this information from the server? So I'm really asking you, what would you do? So the fun fact here is that it's our playground here, right? Think of the most logical thing that comes to your mind, right? It might just turn out that it was exactly what they also did. So when I type this and press enter, as in which is like a new line character, which is telling the server that my request is done, I have left no option or no space for anything else to be told to the server. So suppose I ask for abc.png, or I ask for index.html, or I ask for something else. Can I also convey to the server what my capabilities are? The browser that is connecting, that also can or needs to convey certain information to the server. This leaves no space for that to happen. Actually, with this, I could still see if the server could give me headers. So there must be some headers here that it's very hard for me to get to it here. The server can still give me certain headers, but I have no ability as the client to pass on any information about myself. Okay. What would you change here to be able to do that, to be able to communicate more information with the server? ability to add some metadata to your request. But how would you convey? What's your marker? How does the server know that you're sending metadata? Some flag you would need. And that's a mutually agreed upon thing between the server and the client. But how do you send a flag? In code, you have a variable and it may be a Boolean or maybe some single character, and you know how to interpret that as a flag, right? In this protocol, especially now that this is a text-based protocol, okay, what they did was they evolved 0.9 into 1.0 by saying, I will allow for, so notice one thing, right? If I say http/, when I do this and I press enter, there is no response yet from Google. Okay. Google is waiting for something more. So this is exactly what 0.9 was. But now I've evolved my protocol to, let's say, version 1.0. 1.0 allows you to have some more metadata associated with the request. And the way you convey to the server that the request is now over is, instead of a single new line, it's actually CRLF, which is /r/n or /r/n twice, right? So instead of a single one, you need to have two. Now I press enter once more and data comes. Two new line characters, right? I'm simplifying it. It's like a CRLF, really, right? As part of the protocol. So it's a small change. The change is, until I have two CRLFs in a line, the server waits for me to send more information or send more metadata about the request that I'm sending. Right? It's a very small change, but it's a very powerful one because it now suddenly makes your request extensible. It's a very small change, right? So as part of the talk description, I'd mentioned that these are certain abstractions, and these abstractions enable certain powers in HTTP that allow us to build very complex applications on top. You will notice that this, after the first evolution of that entire thing coming together, I would say this was the next evolution in the evolution of HTTP. It doesn't say it's a fixed length metadata thing, right? It just says, give me as much as you can, as long as the server is willing to support it. And now I can process it. So what additional information can I give to the server? I'm not giving it yet in the GET request. So what also changed was some information that, or something that Anil just mentioned some time back. Can I give something to the server? The change that was really felt, the need for change was felt on multiple counts. Not only do I want to get other kinds of resources beyond HTML, I also want to be able to write to the server. What if I need to upload something? If I am replacing FTP, let's say, let me also have upload functionality. So we saw only get. 0.9 had only get. 1.0 got a few more, right? So we know of get, post, delete, put, patch, right? Trace, options, quite a few of them, right? I don't exactly remember which ones came in specifically which versions, but post, I believe, came in 1.0. And post allowed you to upload information or upload content to the server. That's where I needed to pass on metadata about my request to the server. Not yet in get. Like get did not require me to pass any metadata specifically. Okay.
The decision for the CRLF, was it just because formatting? Like you could have chosen a space for that?
So CRLF, as in an empty, like no spaces and just new line characters, is a very two of them in like consecutive ones is a very strong indicator that I have no more data to give to you. So amongst everything else, see space, I can have space in my request line itself, right? Get space index.html space HTTP 1.0. Then I have a new line. If I have two new lines, it's very unlikely that I missed typing something. It's most likely like I am done. Please continue. So it was a convention. It's a protocol. Protocols are things that both sides agree upon, right? Now, with this change, I'm able to pass on metadata about my request. Okay. This enables certain more interesting things here, right? Now, HTTP only said, this is my change. This is the change in my format. But what does it enable next? If I already have some content, okay, and I want to fetch updated content if it has changed since the last time I checked, I can tell the server, give me index.html if it has been modified since this timestamp. Where would I pass this information? In the metadata. Right? So I can optimize. The idea of giving metadata itself now enables us to extend that in whichever way we would really want to. There are certain things that HTTP makes or defines as part of its standard, but HTTP also does not stop you from passing any additional metadata as part of the request. So you may have also used in your applications your own custom headers which start with something like x hyphen something something, right? As a convention, we say x hyphen something is custom header. And a very common application that we use these days in distributed applications is trace IDs. So it is, I think, XB trace ID or something like that, right? The span IDs and trace IDs. These are custom headers that we introduce into the request. And we also get it back. Okay. So this was a small evolution. Then what came next was people said, I also want this web server. And then there would be system administrators or the network experts who would say that, wait, this is a potential security hole. If every person is going to expose HTTP endpoints on their machine. So in old times, people had labs, lots of labs, and then they had their computers within those labs. And mostly they were all connected to the internet directly. It wasn't a kind of the wild, wild west as it exists today, right? Which meant that if you had any port open, you were potential targets for attack. Now, if I had the ability to run HTTP servers on every individual machine, what would happen is I wouldn't know. I mean, let's say I'm the system administrator of this particular lab, and every one of you has their own computers, and you can run your HTTP servers, and someone gets hacked, information gets stolen. It would be a very difficult situation to be in. So we said, okay, what if I could host, let's say we had lab A and lab B, and both of you want information to be made available to the outside world on your own domains. So let's say you are laba.com and you are labb.com. One option is to set up two servers, two IP addresses, and map them to laba.com, labb.com, right? Okay. But then what HTTP 1.1 did was they said, I will allow for virtual hosting. Let's have one HTTP server, and that one single HTTP, that server could serve multiple domains. And how would the problem be resolved? How would the client convey to the server what resource it wants? So there's a small change. The next one is I would do get index.html http/1.1. Okay. I want to see what Google has implemented, but maybe not right now. The next thing you do is say host. You specify which host you're looking for. So in your case, I would say lab host laba.com. In your case, I would say labb.com, right? And enter twice, and that's it. Okay. So on a single server, I can map two different areas or two different directories and say, from this directory serve all content for lab A, and from this directory serve all content from lab B. Additionally, these two directories, I would give access to individual labs and say, this is your central server. Whenever you have updated data, come and copy them over, and they will be available to the outside world. And we have only one server that will be exposed to the outside world. And now we have a nice optimization. Single IP address, multiple hosts being served from there. Make sense? Okay. All right. While I did this, notice one thing. In all the previous examples, HTTP 0.9 and 1.0, the connection would close. Here, the connection is not closed. Which means that I could do this again. See this on the same connection, and because Google serves mail.google.com also on the same endpoint, or maybe not, but then it gave me a different content because I asked for actually mail.google.com here. The connection is still not closed, by the way. And the response header says, so this is what we had typed, right? And this is the response Google gave me. Now, again, it's up to the implementer to decide how they want to do it, right? This has got nothing to do with what the standards would say. All it's doing is just making sure that the format of the response is according to HTTP standards. So what I do get here is 1.1, 301 moved permanently. This is more of a helpful text, but this is the code 301. So we have 100 series, 200 series, 300, 400, 500, right? So 300 is more of things like moved permanently or moved temporarily, which is 302 and so on. 400 is client side error, 500 is server side error. Look at the other headers that we see. Whenever there is a 301 or 302, you will find a location. And this location tells the browser where to go next. There are certain other policies, right? There's a date expires cache control server is SFFE, which is just metadata, right? All of this is you could very well ignore. What the browser really wants is primarily location, consumes it, and then done, right? The connection is still not closed, by the way. Okay, so on the same connection, let me get now, since it's a very large output, if I could reach the beginning, okay, very hard. You see this 0 here? Any guesses what this 0 is? no more content or end of file. Now, how would you distinguish from this 0 and a 0 which was part of the content? But I could create an HTML file, put a 0 at the end, and still serve it. I would get 2 zeros. Any guess? It could have also appeared here, by the way, but they were just nice and put a new line at the end of their HTML. So someone is saying that this is CRLF, the 0. The CRLF would not print. The CRLF, if you try to print it, it would always end up being a new line, an empty line. So this would not be a CRLF. Okay, so before this 0, if I could have scrolled up enough, and I can even try doing that with a, but I would need to switch window and then try again. So we'll do that, try to do that in a moment. But first, let me explain what this is. This says the content length after this point is 0. And no more content to send. You are free to send me the next request. But then how do I know that this 0 is the one to be interpreted as no more content? What we missed is in the beginning of this information, there was there's a header called transfer encoding, and again in the header what Google tells us is it's a chunked piece that it's sending to us. Okay, so if you have, or if you remember seeing certain HTTP responses, they give you content length, right? What is the content length useful for? If I have now a connection in HTTP 1.1 which supports multiple requests on the same connection, by the way, which is another optimization, because now I don't need to do a TCP handshake again and again, right? For a new connection, on the same connection, I'm able to fetch multiple responses, right? Now, if I had to get multiple responses or multiple pieces of data, I need to know when the server is done before I can send the next one, right? So that information is given to us by content length. And content length is the exact number of bytes after which the response would be done. Okay, and the browser or the client that you write will parse the content length header and then read exactly that much, those many bytes, and process them. Now that's very useful when you are, let's say, consuming binary data, right? In HTML, I know I see /htm. If there is connection close, I know that's it. Connection is closed. This is the data I should consume, right? If there is very specific information about the number of bytes, I can take it, then I can pass it to a decoder, for example, gzip or PNG data or JPEG data, whatever it may be, right? And pass it to that decoder and then render images or uncompress or whatever I may want to do with it, right? PDF file, call another renderer, and so on, right? Because HTTP also does not tell you that the content has to come from a file system, we know that content can be dynamic. Of course, we are now very familiar with it. We write web applications. All the endpoints that get hit, they are typically dynamic content. In dynamic content, it's very hard for you to know beforehand what's the length of the content that you have that you're going to give back, right? So HTTP also allows you to do chunk transfers. What does chunk transfer mean? As I am processing, I generate some amount of information. Let's say I've generated 100 bytes. I know more is to come. So if I do chunked transfers, I can first start with chunk transfer 100 bytes, then the next 100 bytes. Then I have next another 100 bytes. I would first print 100 here. If it is a non-zero one, I will not send the next request. I will still wait, consume the next 100 until this becomes 0. And when it becomes 0 and the connection is still open, on the same connection, I can ask for more. So let's say that Google said I have 100 bytes. Up to this point, it will be exactly 100. You get the understanding now, right? It has somewhere before it has given a number, and up to this point, it was exactly that. Probably including the new line character, of course. And then comes the 0, and this 0 signifies to us that there is now an ability to send the next request. Now, because my headers, so the question is that this information could have been in the headers. If I do not know the size of the content I'm going to generate, I cannot put it in the header. So in the header, I only give an indication that I have chunked data. And then after the header is over, I first start with a number on a line by itself, which is the number of bytes that I'm sending in the next chunk. The client is supposed to parse those or consume those many bytes and then wait for the next chunk or chunk size. So it cannot come in the header because it's not known ahead of time. So it comes as, so the header ends 2 CRLFs, then you get the length of the next chunk on a line by itself. Then from the next line, you have those many number of bytes. And then the next chunk size. When it becomes 0, that's it. So that transaction is, or that transfer is over. Okay. Again, HTTP did not have to change for this. If the server supports chunked transfers, the client supports consuming it, all good. Right? The same thing works here. My request metadata to consecutive new lines. What else can I enable on this now as an optimum? So HTTP is stateless. And we still manage to have stateful interactions over HTTP. How do we do that? So there was a header introduced called the cookie header. You can set cookies on the client side. The client takes that cookie and then makes sure that the same cookie is sent back with every request to the same host. And that allows the server, so if the server remembers which was the cookie I had set on a specific client, it can connect all the previous requests to the same, or all the series of requests to the same client. Right? And so set cookie was a nice evolution here that allowed you to do stateful interactions, that allowed you to now have things like login and personalized access to various resources.
Server has to have that amount of memory to support all the cookies and save all the cookies in the web.
Yeah, so the point that Amit is making is that the server needs to have enough resources to remember all the cookies. Yes, very much. The server would either have things in memory, or these days what do we do is we store in databases, in Redis or Mongo maybe, right? Or even on shared file systems that used to happen once many years ago across, because you would have multiple instances, like like clusters, right? But they were like very primitive kinds of clustering that we had before. Okay. And again, the interesting thing about cookies is you can have multiple cookies. So I can have multiple set cookie headers. Host, of course, we have already seen. Keep alive, we have seen example of that. The connection wouldn't close. So this is also a server ability. It can keep the connection open. Content length and transfer encoding also we have seen, right? Now, what else? So transfer encoding also supports other kinds of encodings, including compressing your output. So as a client, in my request header, I can say accept encoding gzip, for example. The server knows that while transmitting information, I can gzip the content. Now, a file which may be 100 MB big, deflated or inflated, that is, right, could come down to maybe just 30 MB after compression, and we are saving a lot of bandwidth here. Again, these negotiations can happen purely based on the headers or metadata exchanged. HTTP format structure still remains the same, pretty extensible there by itself, right? Another thing is, let's say it's a huge file that I'm downloading, 100 MB, and my connection breaks after 40 MB. HTTP has a solution even for that. I can accept ranges of information to be transferred in my request. So in my header, I can pass information about what range of bytes I want. So if I've already read 40 MB, I can say start from 40 MB plus 1. And if the server supports ranges, it will serve only that information to you. So you can be efficient, right? It restart a transfer. This is how it works. Another problem is if I have, let's say, 2 connections. It's not a problem, rather. It's like a problem of plenty. If I have, let's say, 2 internet connections in my home, both of them 100 MB, 100 Mbps, and I want to download a file which is 10 GB. Can you use both connections for transmitting your 100 GB or 10 GB, whatever it is? This assume that the server has a GBPS link to the internet. It can easily transmit way more than 100 Mbps or 200 Mbps. But you have 2 connections and you want to get your information faster. Can you find a way of consuming from the server from over both the connections? So Amit suggests that I can say connect via the first link, and the range can be 1 to 5 GB. Connect over the second link, and range is 5 GB plus 1 to 10 GB. Problem solved. This was also a very neat trick that downloaders, so in the very early days, when this came out and people had multiple connections, there used to be a flurry of downloaders that were available that people would download, and it would use this trick to consume bandwidth over different connections as well. Right? Pretty neat things that people started doing in those times, very early days, and it was a lot of fun figuring out these things and why these things work. Right? So given that we are around time here, right? So let's maybe have 5 minutes of just audience discussion as well. Did the content here kind of help you relate with how things may have evolved in HTTP? We use these days, if we are doing Java and we do Spring Boot, or we are doing In the Java world, it's Tomcat, Netty, Jetty, Glassfish, whatnot, right? Or Django, Tornado. Django is just a framework, but the web servers that we have, right? Or Apache, Nginx. We're mostly used to dealing with HTTP over this, but at the heart, at the base, it's something that has not really changed or had the need to change much over the last 30 odd years, right? It managed to be very stable in terms of, if you look at the structure has remained very much the same. Even introducing SSL connections, it's just an underlying thing, right? HTTP can work on top of it. The things that started to change very recently, though, are HTTP 2 and HTTP 3. What those bring are a lot of these headers or the messages, the metadata that we have, right? That's text. It requires effort to parse, understand, and do things. So people are trying things like converting them into binary so that they can be more efficiently consumed or processed. So HTTP 2 tries to bring that into aspect so that things can be faster. The other thing that HTTP 2 also tries to bring is, in this case, as we have seen, we can make connections one after the other. So HTTP 2 is fully duplex. I mean, even this is duplex, but there it allows you to mix different requests and get the responses intermingled. Unlike this, where it's a one after the other, in 1.1, you can mix your responses. I could have 2 or 3 different competing processes sending 2 or 3 different resources from the same server. I can mix them and I can send them intermingled. Right? Yes, even with 1.1. So what browsers typically do is they open multiple connections. So one optimization trick that people do is in servers and browser implementation is, let's say that my HTML is huge or is being generated slowly because I am maybe rendering a huge list of emails or whatnot, and there will be different embedded links that the browser would still need to go and download. Until the first page is completely downloaded, I cannot send the next request. So what browsers do is they open multiple connections. On the first connection, as the HTML keeps getting parsed, in the second connection, oh, I found this JS file, I found this CSS, I found this embedded image. I can keep requesting for those on a second connection. I can open more as well, but then that can lead to only a single client hogging up all the sources on the server. So servers ended up having policies that you cannot have more than 2 or 5 or 4 active connections. Then how do you bypass this? Because now browsers started to introduce their own limits on how many connections you can create to a server. So people started bypassing this by hosting their static content on different domains. If you see where Google serves its content from, there'll be mail.google.com and www.google.com, but there'll be gstatic.com, right? Or gusercontent.com or something, like you'll see many other domains from which even Google serves. And you can even see GitHub, for example, also has a different domain for static content that it serves. Right? I don't remember, GHCRIO or something. GitHub content repository, ghcr.io, I think, right? So many tricks, a lot of these things have happened. It's only up to your imagination, because HTTP really did not leave or did not ask you to follow a very specific thing. It just said, follow these standards, and as long as you live within those standards, everything is fair, right? And then people came up with their own, very interesting ideas on top. Yeah, now, so 2 is pretty common now. If you if I hit HTTP, for example, right? So sorry, GitHub. Two. So it responds with. So even curl asked for, or curl said that I support HTTP 2, and GitHub responded with that. A lot of its headers, as you would typically see. And then, so by the way, this request was just the head request on slash. So head request means I don't want the body of the content. I just want the headers that you can send. So 2 and 3 would be very hard to find, I think, yet. But 3 uses UDP. I think it's called the Quick Protocol, QUIC. And UDP allows you to bypass the TCP handshake overhead. Two is pretty common now.
What is the main significant feature of the
2 is binary and allows you to intermingle different responses on the same connection. Without you having to open multiple connections, you can send, even before the first response is complete, you can send the next request or the same connection. And because it's a binary protocol, you can mix things. The message frames take care of ordering, and the client has to understand in what order the message frames have come and for which request, and it can build the response locally.
So in the same response, in the same chat, you can have
In the same connection, you can have different message frames, each for a different request. So it's almost like packets on the IP protocol. Things can appear out of order, and it's TCP's responsibility to make sure that things are arranged in order. Similarly, HTTP 2, I think it's called Speedy something. It takes care of ensuring that the messages are put in order, and then your entire entire response is recreated. So if you recall, in HTTP 1.1, you would have to wait for the previous response to finish before you could send the next one. And that's why people started having multiple connections. So I could send different requests on a different connection. HTTP 2 removes that overhead.
Then, like, does it become very similar to WebSocket or WebRTC, complete two-way protocol? Or does
Yes.
it live on HTTP?
It is on HTTP. So even WebSocket is like an upgrade.
Okay.
So it's the same connection. You don't open a new connection.
Okay.
And interestingly,
like the previous case, it kept on persisting.
Yes. It's just that the protocol changes, which means that the way you parse your information after that protocol switch happens, only that changes. So it's like your implementation switches to a new one, and on the same connection you can continue.
more of a inference, right? I don't know whether it's correct or not, but I was just basically trying to serve more content. The reason why we are upgrading HTTP 1 we just serve more content, and we talk about we said it also just basically able to serve a lot more content at a higher speed.
So there are, I think, two major things that we are attacking here or optimizing on. One is the connection establishment time. With more connection establishment time, so not only TCP has an overhead for connecting, SSL handshakes are also pretty latency inducing. And these days you would want everything to be on SSL. So both of them introduce a lot of latency. And latency is generally a problem which the big players would really want to solve, because there had been a study that for every 100 milliseconds of reduction in time when you start seeing the first render, the user engagement goes up by a substantial amount, right? People tend to stick around if they start seeing content quickly. If your content doesn't show up for example, 10 seconds, people wouldn't even stay engaged. They wouldn't even want to visit. They want the first rendering has to be quick. It's a very impatience thing, right? People tend to be that way. So that is what we are optimizing on. Second is if I can do everything on a single connection, I'm consuming less resources of my server infrastructure, of my browser as well. So we are optimizing on both of these counts.
Generally, how much time it waits? How much time the browser or client waits to speak for the connection?
That is a configurable thing, and in some of the headers, you might even see what the timeout looks like. So a very good way of looking at some good HTTP configurations is to open your browser, the Chrome browser or any browser in the developer mode, look at the network console and look at individual requests. Look at the request headers, the response headers. You can even observe your WebSocket messages. Thank you. You can even observe WebSockets and the messages exchange and their message frames and so on.
The latency then is coming at a cost, right? Because we added SSL as a
the latency is typically in the SSL handshake part. And once the handshake has happened, then after that, your connection is like, it's almost the same kind of. The handshake is your overhead, which is not really productive from the core interaction point of view. But once your SSL connection has established, it's minor CPU utilization increase, but that's easily taken care of. But your network latencies are like they're out of the picture now. It's just your network speed and individual packet latencies. So if I, let's say, so let's say I pick one, right? Now, even in google.com, there is an embedded link for play.google.com. Somewhere it might tell me like download Chrome from blah, 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 right? For your request method is post, address, response headers. Okay. Purely this response is as a JSON, right? Headers, payload. This is the form data that this page sent to play.google.com. So you could go through all the links that get invoked as part of loading my google.com page. This is hard to see, but I think developer console is a very commonly used tool. You could use developer console in Chrome and even other browsers, and you should be able to see individual HTTP interactions from the browser to your server. And it's a very good way of learning. You can look at cookies, you can look at no, I don't think it's readable, but I believe people would be aware of the developer console. So I think that's mostly what I've had. We can, of course, keep going on based on any discussions you'd want to have. Any comments, any points you would want to make?
I think there was some also discussion. I don't know whether it's 2.0 or 3.0. The body of the HTTP request is getting bulkier. They are also trying to optimize on that. Is it 2.0 or 3.0?
So the point that Amit is making is we are trying to reduce the overheads in terms of the metadata or the request body that we send to the server every time. I'm not exactly sure about that aspect, but probably it sounds very logical that given that we can do multiple interactions on a single connection, and we know that the same connection is meant for similar purposes, a lot of the repetitive metadata or the headers that go from the client to the server, they are avoided. So logically, that sounds like the right thing. Like, looks like it should be so.
What kind of application do you see as Web3? What kind of application do you see coming to the web from desktops?
So to be honest, I have not really followed the Web3 discussion that has been going around. But I have been hearing about the semantic web or the linked web for a very long time. I don't think we have cracked it yet. Things. No, semantic web is. I'm not sure if you're referring to the same thing that I'm referring to, but semantic web is. So semantic web is a. So you could. I will try to give a very overly simplified view of how it is. So let's say I have an HTML page which has content, right? Or imagine a Wikipedia page. It has content about a specific topic. Now, let's say it is a Wikipedia page on Pune, and one part of it tells you what the population of Pune is. Now, visually, it's very easy for an HTML designer to highlight that part, put it in a box, and a human can immediately find it. But if machine had to make sense of what the population of Pune is in an automatic manner, not using natural language processing, but rather through way of some structure inside the document. So semantic web tried to evolve a set of standards by which you could annotate interesting information within documents by associating certain meanings with them. And when I say meanings, there would be like a predefined set of standards of taxonomies that they could associate with parts of information in your page.
As well as I remember, I think in one particular language style also, where we got to festival where you can find the web page where all the content for the
OWL, I think, is one. And then there is OWL, then not HTML type, but there's something called Resource Description Framework, RDF. And then there are mechanisms to query relations using something called SparkQL. It used to be like, worked upon quite at some point in time, but I believe deep learning won, right? So people thought it's easier to use deep learning and extract information rather than have people structure their information in a very proper manner.
the inertia of creating content is
Yeah, that was the thought process that, so since deep learning is now able to extract what we really want, why make people, why push people to have more structured information, because it's a lot of work.
that's why so like semantic web it is getting solved and it is getting good. I'm sure it might be at the best level of it where it can't affect relation.
So my response was actually to the question, what about Web3? I'm not sure what Web3 is. If it is related to more structured web of content, then that's where I was coming from, but I really don't know the answer to that.
Web3 for me is more towards decentralization. I don't
Oh, okay.
That's a different thing. That Web3 is okay. I think so.
Okay. The quickest thing that Google tells me is Web3 is something based on blockchain technology. So everything today can be blockchain now. No, Google has a snippet using machine learning that tells me exactly the definition.
Blockchain is the whole idea is of a blockchain is also very is to decentralize information. Basically, replicating the same information at multiple places, and you have a way of verifying that it is correct.
Yeah, but I wouldn't really know or be able to guess in the context of Web3 what they're trying to do.
Now we have seen this HTTP protocol. It's normally between the client and server. Some of it's thing, but I'm not sure if you're going to see that you can specify a documentation or something like get me this source from this particular machine. Like if you look at the client, you have different web this running. I'm not sure if that is
So I
thought that that's connected in the protocol. That's not going to be there.
so can you please repeat again? I did not.
Protocol is basically between the server, like this thing. You're talking to the server and telling about what to do, get me something or get me something. Let's say I want to compute something locally. So I know that can compute in my machine. So I can send an instruction directly to my local machine and say that get this thing computed in my other browser or something like that. I take from there instead of sending that request to the server directly. So,
Okay, so your name is
Anand.
Anand. So what Anand's point is, I'm repeating for everyone's, and correct me if I'm wrong. What Anand is saying is there a possibility of, or is it possible to have or reuse the web framework that we have, but do distributed processing, where I could have instructions sent from one place to another, could be browser to server and server to some other browser, and have web workers do something. Maybe there is, because I've heard of Bitcoin mining inside of browsers as malware installed via JavaScript or malicious JavaScript by websites. So it's doable. You could probably, or maybe it's even being done.
There is an actual project which where they're using multiple different machines and they contribute your machine to sequencing.
But in the browser?
I don't think it's in the browser. You can use this not the assembly. That's program simple that the client side and you can do the processing in assembly.
Yeah, I think you can definitely, so if you can imagine a particular kind of execution, you can definitely do it, because Wasm enables a different kind of computation within the browser. If you're willing to give your browser CPU for a specific purpose, it should be doable. But that would be completely independent of the HTTP protocol itself.
They're trying to ask something, but
With chat here.
they're saying that they're not able to.
Can't unmute. I think it's. Oh, can you
Maybe
unmute?
they can ask on the chat. Meanwhile, I'll try to see if there is an option. Can you ask them to?
So on Zoom, if you have any questions, I'm sorry, I think we will not be able to unmute. If you could ask questions.
Type in.
And thank you for your comments.
Can you try it now?
Yeah. Hey, hi, Jaju. Can you hear me?
Can they guys try to unmute themselves now?
Can someone try to unmute and speak? We
Yeah,
have
Jaju,
enabled,
can you hear me?
mics for everyone.
Hello. Yeah.
You
Can you hear me?
We can't hear.
Okay.
Yeah, try speaking.
Yeah, Vinayak, can you hear me?
Yes.
Okay. Can Jaju hear?
I'll move
Okay.
closer.
Okay.
Yeah.
Hey, Jaju, this is Yogi.
Hey, hi.
Hey, so there's a question which comes to mind is that is there certain inevitability about the success of this protocol, similar to protocols like TCP in a certain sense, right? Because I mean, once there was adoption, then there was viral adoption. Then going back away from this to another protocol would require such a huge change that the effort was just not worth it. So the question is there something truly simple or elegant about the HTTP protocol?
Okay.
Repeat the question.
You repeat the question. Yeah.
Hey,
Yeah.
wait, hold on. Karun, can someone please mute host mic, because we're getting an echo.
Yogi, can you repeat your?
Yeah, can you hear me? Am I audible?
Yes, we can hear you, Yogi. You're audible to us. Probably
Okay,
not there.
I think not there. Okay.
Yeah.
Okay, maybe I'll just type it in. If
You
there's
have
a
to type
problem.
it. We're not able.
So I will try to repeat what I understood from Yogi, and Yogi, if that question is accurate, if what I repeat is accurate, just let me know. So was your question about the fact that this got adopted and became very widespread? Did that does that make the adoption of something that may be more efficient a hard one, because now it's very hard to come out of this ecosystem? Is that what you asked? Say okay. So I will repeat the question. Was the success of HTTP inevitable given the adoption, or was there something truly special about its design? That's I can only try to give a perspective, but I really don't know. So one thing about protocols in general, that if you compare HTTP with, let's say, even FTP, they seem very similar. In the sense of not really the exact request response structure, but in terms of very simple commands and very small set of things that they enabled, and they were made for very specific purposes. The two key things I believe made HTTP really successful are: one, they removed a lot of barriers in terms of information exchange, which was typically much harder. They kind of, in a way, democratized publishing of information, because HTML was very simple, and the idea of HTML itself enabled very quick generation of content, which was cross-linked across servers which were completely unrelated. So I could now link to information from totally unrelated set of people. In FTP or any other place, discoverability was not that easy. But if I discovered something and I needed to share it with others, then I could introduce that link in a HTML page that I was maintaining. It was very easy to update, very easy to publish. And the other thing that really went very well was the idea that when Tim Berners-Lee's group released this, it was actually HTTP, the protocol, a server implementation, HTML, and a client. So essentially, they gave the entire ecosystem, which was like, oh wow, this is like, take this entire thing and use it. It wasn't like, okay, I've released the FTP protocol, now someone go and figure out a client, or just the FTP protocol and the client, but rather a completely usable package that was very easy to get running with. And because there was a gap, or there was kind of a void in the need for information sharing around that time, it became a very uh, you know very easy thing for people to adopt, because they found it very useful. Yes, so HTML was a very key thing as part of the innovation. Uh, uh, but here's a counter thought. If you look at browsers also support FTP, and I could have FTP servers hosting HTML files, which again are clickable, because the browser could now connect to FTP and allow rendering of the HTML files and allow me to click. But if you notice one thing, FTP connections would take very long to be established, even within the browser. So my experience wasn't very great. Second is, it assumed the existence of the anonymous account on all the FTP servers. HTTP kind of did away with that need. It just made that endpoint accessible without the need for any kind of a authentication. So maybe it was a combination of these factors, the speed, as well as removing a lot of this friction that enabled HTTP to succeed in the way it did. And around that time, very interesting things like Netscape came up with its browser with support for rendering multimedia and frames, etc. They started pushing for very quick evolution, and FTP probably wasn't well placed to evolve that quickly, but HTTP, like once once people figured out that these people were also aligned, or that group was aligned with evolving quickly because they wanted to make information sharing easy, it became easy for browsers to also influence the evolution of HTTP. Around that time, Netscape also released JavaScript, which made the web dynamic. So it was a nice combination of many things happening together. So yes, maybe it was definitely a very special set of things about HTTP. In hindsight, it does look like others may not have succeeded as well. HTML was definitely a big key part of the game. Thank you. No, the thank you was to the comment, but yeah. Any more thoughts?
So because the protocol basically also there was an economic proposition as well. It was not just about technology; it's about the people saw. So they evangelized this thing into something that went through like that. Otherwise, it could not have been like that.
Yeah. So interestingly, the money making came 5 to 7 years later in the entire HTTP thing, at least from what I have managed to remember from things. But in the initial 5 years, 4 to 5 years, it was primarily about like, hey, new protocol, browser, abilities, let's start doing these new things.
Netscape came in that time, this was going on like that was.
But that was 95. Netscape was 95. It's still like from 89, 90 to 95. Things were mostly in the in the evolution space for HTTP. So the question that PD has asked is, does SSL handshake happen once per request and the browser can remember things, or it needs to be done every time? Every new connection of SSL needs a proper SSL handshake because there is randomized initialization for every connection. So even though the certificates, etc., are known, your random seed creation and the key for encryption and decryption, that is decided for it's a different one for every new connection. So there is a TCP overhead and then there is an SSL overhead, and with security we always have these two overheads. Yes, HTTP is stateless. So so browser can cache the content, but information about the connection itself cannot be cached because the information exchange has to be encrypted and decrypted either ways, right? So I would encrypt before transmitting. The keys used for encryption and decryption, they are decided on a per connection basis. They cannot be, otherwise it would open you up for replay attacks if you would cache any of the or use previous keys.